Good morning, everybody, and thanks for the kind introduction. So, I'm going to talk about continuous delivery and what that actually is. Why would anybody do such a mad thing? The requirements for doing it, how to do it, so the architecture and the technologies behind it, at least some variety of it. I will show you for a small example project how it can be done, and then I want to talk about my experience doing that at my current employer. So, what is continuous delivery? Continuous delivery is the practice of deploying every good commit to production or a production-like environment. So, that means you write some code, you commit it to your version control system, and it magically ends up on the production server where everybody can use it. So this entails building the software, likely packaging it in some format, determining which commits are good enough. So there are one or hopefully more testing stages that ensure that if you break everything, it's not automatically deployed to production. Then there's the deployment to various environments. So maybe a testing environment, a production environment before, hopefully a staging environment, maybe performance testing environment, security testing, stuff like that. And then the actual deployment to production, but that can still be withheld as a business decision. So your business might decide, we hold back that feature until the big 2.0 release, so you don't actually have to do that, have to deploy it automatically always. So why would anybody do such a thing? And there are actually many reasons, and I want to spend a bit more time than usual on the reasons, because I want to convince you to actually do that, considering continuous deployment. Or if you're already convinced, then maybe you need some reasons to convince your manager or superior or your coworkers or whoever. So I want to convince you. The first is rather obvious. If you automate something that you did manually before, you save time. So ask yourself, how much time do you actually spend preparing your release, coordinating with the ops people, doing the actual deployment, maybe not your work, but of a deployment team, fix up problems afterwards when something went wrong, and then the nice meeting afterwards where you do a post-mortem, and try to decide what to do to prevent further breakages. That's also time that actually goes to the whole deployment process. So if you automate this process, you save some time. Oh, sorry, it's too. The second reason is related. So if you have many machines or many applications that you deploy, or you deploy to several environments, then it actually takes some time, and so you're limited if you do that manually. And if you do that automatically instead, it's no problem to add another machine to your setup, or to deploy a new component, or to have a new environment to which to deploy to, because the automation doesn't care if it deploys to 7 or 12 servers. So you don't write software just because you want to write software. You're usually getting paid for it by a business who has a good reason to pay you. So they want to achieve some actual business goal, and they want to achieve it sooner rather than later. So time to market matters. But there are companies that release only once a year or twice a year, or some projects never get released, so they die before. But yeah, it's actually much more likely that a project dies which has never seen any users, because there's no advocates who say, I love that software, please let it live. So time to market matters. And if you're deploying infrequently, you're actually limiting your time to market by the deployment cycle. So, and that applies to everything, even if it's just a very small usability fix, if it's one line of CSS that fixes the web page in most modern browsers. If you're limited to a deployment cycle of twice a year, on average, the time that your fix hits the actual user is still a quarter of a year. So the manual infrequent release cycles limit the time to market, and continuous deployment can help you crack that barrier. So related to the time to market is also the feedback cycle. So raise hands, who of you has ever received a perfect specification for a non-trivial feature to implement? Okay, I guess so. So you can only write good software by trying it out, getting a feedback, and if it's not software for yourself but for somebody else, it's that somebody else who should give you feedback. So you have to bring the software in front of those people, that in front of your users, and gather feedback and then improve based on that feedback. And the shorter the feedback cycle is, the more of these cycles you can get into the same time slot, and the better your software becomes for the user. And on the other hand, if your feedback cycle is 2 years and you might not even get every fix into that one release cycle, then users will become so frustrated that they don't even tell you about their experience anymore, because they make the experience that it doesn't matter. Maybe they'll leave the company before their favorite bug is fixed. So continuous delivery can help you with that. When you have a shorter time to market, you also get a faster feedback cycle, and you can improve the quality of your software. Then concerning reliability, there's what I call the vicious cycle of the big manual releases. It starts by releases being considerable effort here at the bottom, so you do fewer releases. But that means that more changes accumulate between 2 releases, and so the release becomes rather big, and there are a lot of changes you have to do. More configuration changes between 2 releases, more database schemes must be changed, and so on. And so there's more potential for things to go wrong. And when things go wrong, you try to figure out why things are wrong, and you establish processes, more quality assurance, and so on, to ensure that the next time it doesn't go wrong. And so what happens? It becomes more effort. And since it becomes more effort, you're less likely to release more often. You do fewer releases, more changes accumulate, and so on. So that's some kind of vicious cycle, which often leads to these 1 or half-year release schedules that you see in conservative organizations. And you can counter that by the corresponding virtuous cycle of automation. So you start to automate stuff. You have less effort that go into a release. And if it's less effort, you do it more often to get your stuff in front of the users. And so fewer changes accumulate between 2 releases. And so the actual changes between 2 releases become smaller. There are fewer adaptation needed. There's less trouble. And the time that you previously spent in post-mortem sessions, you can now spend improving your deployment infrastructure. So you automate more, you put more checks into place, and you have less effort, and so that cycle reinforces itself. I mentioned earlier that continuous delivery or automating deployments actually gives you the freedom to deploy more components. If you don't have that, you always feel pressure to put new features into existing components, even if architecturally that's a bad idea. But if deploying a new component is just a few lines of configuration and then the press of a button, you don't feel that pressure to put new features into an existing component, so you gained architectural freedom. And there was a blog post by GitHub. They switched from Git to libgit for their merging feature of pull requests. And they tested it on some of their repositories, and it worked great, but they wanted to test it on real live data. So what they did, they deployed 2 versions of their software. They have a service-based architecture, and they simply routed all the merge calls to 2 services, to the new and the old. and recorded the answers and had some diffing when the two services gave different answers. So they looked at that, and they actually found bugs both in the new and in the old implementations. And so they deployed fixed versions of both. And they also recorded the timings. So they found a pathological case in their new implementation and fixed that, deployed a new version, tested it again. And when they ran it for a week or so without any differences, they gradually switched over to the new, and in the end they switched off the old one. But you can only do that if you automate this whole process from code to deployment to the running service, because otherwise it's just way too much effort. Continuous delivery doesn't automatically give you such nice tooling, but it's a prerequisite for actually doing such fancy quality assurance. So you might ask, do you really want to deploy every good commit to production? So there might be regulations that prevent that. You might need a formal audit or something. You might have SLAs, contracts with your customer that prevents, that limit deployments only to certain hours to patch windows. Or you might need manual review for political reasons. In these cases, you still can do continuous delivery into your staging environment, and then only when these constraints are fulfilled, you can do the deployment to the actual production environment. But it's still a good practice because you can, at least for internal users, you can show them your code in the staging environment, and you keep your code releasable. So, hoping that I've convinced you now that this thing is a good idea, I want to talk about the requirements. Can you do continuous delivery? So there are a few requirements, and the first is hopefully very obvious to you: version control. So if you're not using version control yet, start by doing that, and continuous delivery can be a second step afterwards. But you really have to have both your code and the tools for building your codes, like make scripts, make files, script runners, whatever that you use for building your code. You must have that under version control. Otherwise, it's far too easy to lose overview when you're starting to deploy many versions. And ideally, you also have the configuration of your environment under version control. So you use some kind of configuration management system and have the source of that under version control. But that's not actually a hard requirement for doing continuous delivery. We started out without that, and it still worked. So, of course, if you want to automatically build your software, you must have some kind of server on which you can run this build, and you must also have the infrastructure to test your software and to deploy it. So if your production environment is locked down and you have no access to that, and nobody gives you access to that, you can't do continuous delivery into that environment. So talk to your operations guys. They might actually like the idea because it's less work for them. They all do the manual work of deploying, and if you automate them, you're actually making friends. Talk to those guys, get access to the environments and the infrastructure. So there's a soft requirement. It's easier to do continuous delivery with a server software, so a web application or some kind of service-based software, because your users, if you're writing a classical desktop application, they won't give you access to their computer just so that you can deploy your software onto them. In that case, you can still deploy to a repository from which the users can download this. It can be either a simple website, or it could be like a directory with some indexes, and then your software might have some auto-update features like current versions of Chrome and Firefox do, and so you get some sort of automatic and continuous deployment by them polling for the new versions. But again, it's easier for something like web application. So Oh, it seems I'm missing a slide. One thing you also need is tests. Without any automated tests, it's a bad idea to deploy each commit to production because things will break. So you don't need 100% unit test coverage, but you need enough test coverage to be confident that your commit didn't break any vital features, or depending on the requirements, maybe that they didn't break any features. Depends really on what your business wants. So write automated tests, and as I said, it doesn't need to be unit tests. Integration tests, acceptance tests can work fine as well. So how does a deployment system look like? The architecture is usually that of a pipeline, which means you have several stages. You start with a commit in your version control system, then you have a build stage, a unit test stage, and then deployment to some testing environments, maybe integration tests, maybe functional tests, maybe performance tests, and so on. And each stage only runs if the previous stage succeeds. And each time you do a new commit in your version control system, a new instance of that pipeline is created. So when you're doing some kind of automatic or continuous delivery, you have to make some choices of technology. And the one that most other choices hinge on is the package format. So some people just make a tarball of their software or use rsync to copy it. I tend to avoid that because if you use a, let's say, sane packaging format, the installer will automatically resolve dependencies for you. So if you need a libmysql, the C MySQL client or something like that, and you declare that as a dependency of a RPM or Debian package, then that will automatically get installed for you when you install that package. And if you have a separate operations team, make sure to pick a package format that they are comfortable with. That typically means a system package format like Debian or RPM files. But if you're like working in a pure Java shop, but what are you doing in the Perl workshop? Anyway, jar files might work. If you're working in a pure Perl shop, Perl packages might work. Yeah. So for my example project, I'm going with Debian packages because I happen to use Debian and derived distributions a lot. So after you decided for a package format, it dictates the format of the repository. So you download Debian packages from a different repository than you would with RPM or jar files or Perl packages from a cpan-like. And so you need some software to manage that repository format. And for Debian, I recently found aptly, which is a nice command line tool. There's also DAK, which Debian itself uses, and DebArchive, which kind of work, but are not that easy for automation, in my opinion. Then there's a more enterprisey thing called Pulp, which is developed by Red Hat, and it's a rather generic repository engine, and it has built-in support for RPM, but it also has plugins for Debian and Python, cheese shop packages, and several other formats. For Perl, you might want to use cpan mini and cpan mini inject for adding your own packages to that cpan mirror. Deployment also means installing the packages somewhere. So again, that depends on the choice of package format. And for Debian, you might just want to use apt-get install, or for RPM, it's zipper or yum install, and then the package name. Or for Perl, it's cpanm, and so on. But it turns out that this is all kind of busy work, and there are already tools that automate that for you. So if you use a configuration management system, they typically have plugins for installing Debian or RPM packages, or even Perl or Python packages, and so on. And so a Perl-based solution would be Rex or Rexify. There's also Salt, or what I use is Ansible. That's a Python-based thingy with YAML configuration, and it works quite well. So it has a a very, very friendly learning curve. You will want to use some kind of integration tests. So if you have a website, check if this website came up, if it can talk to the database. Just retrieving a single URL that you know talks to database can already detect like 50% of the most common errors when configuring your package. So you could use something like the gpw mechanized test power module, or maybe something even simpler, something command line based, wget or curl. For a command line application, you could use expect. And then if you have a good operations team, they likely have already some monitoring checks for your application. So there are like Nagios or iSinger plugins. And if you already have such a thing, you can also just run that plugin on the command line to check if your application is up, and do that right after deployment to get immediate feedback. You don't have to wait for the monitoring system to try it 5 times and then give somebody a call or something like that. So we are nearly done with technology choices for now. The last thing to remain is the code that organizes this whole pipeline. And while there are people that do that with simple shell scripts, that's usually not a good idea, because you want to distribute over several servers usually, and you want to collect metadata and so on. So there's software that's written specifically for continuous delivery. The tool I'm using is called Go Continuous Delivery. It's by ThoughtWorks Inc., and it's an open source Java-based tool. Other people tend to use continuous integration tools because they already have the infrastructure for pulling from a source code repository, running the build and the test, and then deployment and more testing is just more stages after that. So if you already have a Jenkins running, you can use, for example, the promoted build plugin to manually promote a build for installation in a production environment. And there's also Atlassian Bamboo, of which I've heard good things, but which I haven't actually tried myself. So I have a very simple example project, which I'm going to show you how to deploy it automatically. And you can find it on GitHub. And I'm using a very simplified pipeline here. So I have no tests. Bad me, I know. And so I'm just doing from source to build, then uploading in a repository, and then deployment to a test environment. But from there, deployment to a staging environment is basically the same technology, just used a second time. So this is my example project. There's some code. It's a Mochalicious Lite application, which just prints a list of installed packages on a Debian-based system. So it executes dpkg-l, which simply lists all known packages and whether they're installed, and it renders that as text. So that's our source. And now for building a Debian package out of that, there again, here's the slide. So you can use the dh_make tool to create a skeleton of Debian files, which can be used to build your package. And then in Debian/install, you can simply list additional files, which will be installed for you automatically. In Debian control, you add metadata like the name of the source package, binary packages, dependencies, and stuff like that, build dependencies. So as a security conscious user, you don't want that application running as root. You want to run it as a separate user. And you can use the post-in script to create that user if it doesn't exist. That's if you want to look at how it's done, it's all in that GitHub repo. So that post-install script runs automatically after your package has been installed. And then I use systemd to control all these services so that they're getting automatically restarted when a new package is installed, and that the service is start up at boot time. And so you can write a service file, and the Debian tools will also include that for you more or less automatically. Once you have that all in place, you can invoke the dbuild command. B minus B means build the binary packages only, no source packages. And USUC means don't sign that packages, because the repository management software will do that for you in the end. But there's a problem. This command takes the version number from Debian/changelog. And if you commit twice without changing that changelog file, you recycle a version number. And that's a bad idea, because Debian thinks that a combination of package name and version number is a unique identifier for a version of that software, which is a sane assumption. So you must use something else. I've come up with a small shell script. It uses git describe, which basically gives you the last tag in the Git repository and the numbers of commits since that tag. And then this Go tool, which controls my whole process, gives me two environment variables, the pipeline counter and the stage counter, and they increase monotonically, so they're good things to put into a version number. And then here in the second to last line, I invoke the dep change command, which simply writes a new entry in the Debian/changelog file. And so the dbuild command picks up the version number from there. So that's a small tool which I put in a second Git repository, because remember, your build scripts should be under version control 2. And this is like very generic. It's not tied to this particular project. It works for all projects which derive their version number from the Git tag. So it's in a second Git repository. To create a new Debian repository with aptly, you simply run aptly repo create, and in the end you give it a name. It's here staging the last word on that long line, and you can give it a list of, you can give it a distribution, which is like the Debian version that you build for, and a list of architectures. And you say aptly publish repo, and then the name of that repository. And once you have a package, you add it to that repository with this aptly repo add, then the repository name, and then the Debian file name. And then you have to update the published files. So these are files that you point a web server at, and then a Debian host can fetch the packages from there. And so you run aptly publish update, and that then not the repository name, but actually the distribution name. That confused me in the beginning, so don't fall into the same trap. So as I said, I use Ansible to install packages. Ansible uses what they call an inventory or a host file, in which all hosts are listed, or all servers onto which the software should be installed, and with which Ansible should talk. And so there are sections. I have a section web for web servers, and then there's like a special section, all : bars, where I can set environment or Ansible variables for all of these hosts and all of these sections. And so I simply say Ansible use the root user and not use I think the default is an Ansible user, and then you can use sudo or something like that. And once you have that inventory file, you can specify it with -i and then the inventory file. And so a nice trick is to have a separate inventory file for each environment. So you have a separate inventory file for staging and a separate for production. And so by specifying an inventory file, you also specify the environment to deploy to. And then the next argument is the section. You could also add a specific server here, but if you want to deploy to all servers in the web sections, just use the section name here. -m loads a module, and the apt module, you guess it, will use apt-get to install modules for you. And so the -a is the actual argument to that. Name is the name of the package that you want to install. Update cache means run an apt-get update, so get a list of all available versions of the packages from the repository. And state latest means upgrade to the newest version that's available. And that's basically it. Now we have all the steps we need. We just need to plug it into this Go continuous delivery tool. And so it has both a web GUI for configuring these pipelines and stages, but that's like a lot of clicks. I don't want to show it here. So there's also a very human readable XML configuration. It starts with materials. These materials are, on the one hand, things that trigger the pipeline. So there's a new commit in a Git repository. It will trigger the pipeline. On the other hand, Go makes these repositories available in the file system when it runs your build commands. So then we have a single stage which I call build, and it has the clean working directory true, so it will actually clean everything out for you. And then within that stage, there can be several jobs that run in parallel, and within a job, there can be several tasks which run serially. And a task can be as simple as executing a system command. There are also specialized tasks for Maven builds and stuff like that. And in the end, I collect what they call artifacts. So artifacts are files that are created during the build, files or directories, and they are added to an internal repository, an artifact repository, and later stages can reference and retrieve these files to, for example, upload them. So here's a screenshot how it looks. As I mentioned, there's a web GUI. Here's the list of all pipelines that are configured. There's only one here, which is called package info. And the green bar means that a stage ran successfully. And you might see this label 6. So this pipeline ran 6 times so far. And here I've added more stages. So for uploading to the staging repository, for deployment to staging, and then the same for production. So upload to a production repository and deployment to production. And I've made one of those stages fail. And so you see a red bar, and the stages afterwards don't run. So you don't want to deploy to production if the test fails. And that mimics that behavior. There's also a history view. So you see afterwards I made this stage pass again. And so it's now green. And this like double arrow thingy with a vertic bar in the middle, that's a manual approval. So it only goes to production if I press this button. And if I do and wait a while, it looks like this. Yellow is means it's still in progress. So there's JavaScript polling the status updates automatically. That's actually a very nice user interface. Sorry. And then there's also a view which they call the value stream map. You can see the 2 Git repositories as round things. So actually one is a bit shadowed because when you click on that, there's a pop-up and you can see which version of the Git repository went into building the software. And if you have several, you can see from all of the repositories. And you can also build whole graphs of pipelines. For example, you can run 2 pipelines in parallel and join them together. And only if all of them succeeded will the next pipeline run. And so this is actually very good for tracking installed software because you get both a timestamp and the individual stages and the version numbers of the software you build and the versions from Git. So if an auditor asks you at this point of time which version did you have installed, you can actually trace it back to the Git commit of each involved project and basically recreate the software at that time if you need to. You can also look into the actual stages. If you press on one of those bars, green or red, which represent the stages, you get a view of all the output, and you can also go to the artifacts that were captured from that stage. So finally, I want to talk about my experience. And if you remember, the talk of the title is Continuous Delivery, Pipe Dreams and Realities. So there are some very steep goals and dreams in that continuous delivery world. And the dreams is that you automate all that stuff. So you start from a single commit in your version control and it's deployed to production, but it also goes farther. So the advocates also say you should like be able to deploy in a whole environment just with a click of a button. So create new virtual machines, a new database server, provision all that, and so on. And so that seemed like very steep goals, and they advocate that you should do not only fully automated deployments, but also rollbacks if things went wrong. So initially, I was rather scared of these things because they seemed unreachable. But I found that starting with only automating those parts which cause you the most pain and the most work is actually a very worthwhile experience, because you pretty much save time right from the start. And when you do that, the bottlenecks shift. So if previously the build was what consumed the most time, and that's gone now, then the next step will probably uploading to a repository, which is taking the most time, and you automate that as a next step. Or if you have many machines, installing it on all of these machines takes a lot of time. So that's the step you automate. And partial automation is very valuable. It's still much better than doing everything manually. And finally, rollbacks, which seem like a scary concept, are really just installation of a known good version. So that's actually not very hard once you know how to install a version of your software. You must just record which was the last good version, do a small check, and if that check fails, reinstall that good version again. So I mostly develop tools that are used internally, and time to market isn't such a big deal for us for new features, but it is for bug fixes. So we have a web application, it's a ticketing system, and it's used very heavily inside the company. So if that doesn't run, people say they can't work, and that's 90% true. So if that thing breaks, we are very happy to have a short and fast and reliable way to fix it and get the fix not only to the staging environment, but to production. So we have that application is very heavily patched internally by us. We have like 4,000 custom commits. And each time there's a new upstream major version, we upgrade to that. But we break lots of our customizations, and we have a huge test plan, and we go through that. And we still catch things that break when we roll out to production. And so I did that in February, and within the next 4 work days, I did, I think, 9 releases or so, fully automated, and with no downtime. Nobody noticed except those people who had noticed the bugs. And then at the end, I wrote a blog post with, these were the list of bugs we actually fixed in the last week. And so that was very good, not to have to coordinate with the operations guys to get the fix to many users. It's also very convenient if you have a security update that you want to get out of the door very quickly. Managing state, and by that I mean managing persistent, usually database state, and its schema is hard. So I've been working on this deployment thing in addition to my actual development job for about a year now, and we still don't automate database upgrades. And there's a very simple reason for that, that whatever you do, either the operation itself or its rollback will lose that data for you. So imagine your database change involves deleting a column. When you do that, you can roll back to the previous version by re-adding the column, but the data in it is lost. So you would need a very elaborate scheme to restore that from a backup, but then new rows would have been added in the meantime, and they were unable to add that to that column. So that's part of the difficulty. Or if you add a column, then the rollback of deleting the column loses data. So no matter what you do, it's a very hard topic to automate. And the best advice is, if you're already using find a software that already does that for you. There are solutions. There are not many of them, and few of them work very well. But if you can find one, use that. Also, it helps if you have cooperation from the development process. So if you want to introduce a new column and make it mandatory, it's much easier to do the database upgrades if you first introduce it as optional, so no null is possible. Then you do the database migration, you fill the column, you deploy the software that uses the column, and when you're confident that you don't want to roll back onto a version that doesn't use the column, then you add the not null constraint as a later step. And that makes that database upgrade much easier. I also found that the big tools like this Go continuous delivery have a rather steep learning curve. So at the start, I was quite frustrated, and I was actually considering writing my own shell script to do that whole pipeline automation. But after getting used to it, I realized that there are many benefits to using an existing tool. It does quite some work. For example, it allows you to compare the sources of a good and a bad version of a deployment. So you get a nice diff in there. You get version tracking. You get that artifact repository. You get a user interface where you can actually add permissions. So you can give your ops people the permission to deploy something, but not to change the configuration or stuff like that. Or you can even give a manager that green button for deploying a new version, so you can make them feel in control. I also experienced that the advantages that I advertised worked for us. So the time savings are real. The faster feedback is also real. So we used to have about one release a month, and now we have about one release per feature that we implement. And many of our features are very small, so maybe half a day or a day of work. And after that, we show it to somebody who wanted it, and they say it's fine, and we actually deploy to production. And then in the end, we tell everybody about it, or we don't, depending on the feature. And it also reduced stress levels, so fewer deployments go wrong. We're more relaxed. I actually started a deployment of that ticket system before I went to lunch break, and it worked. I wouldn't have done that a year ago. Scaling to more components worked for us. We're currently deploying about 2,000 components automatically, and many of those are new. We couldn't have scaled to that many components with manual releases. And basically all of the big successful tech companies that you can think of, Google, Facebook, Spotify, Netflix, they all do continuous delivery. And for them, it also works. So there's some kind of social proof here. All in all, it has been a very worthwhile experience, and you should try it. So thank you, and I want to make a very small plug. I'm actually writing a book on all this experience and these techniques, and you can find the notes on it and the mailing list and the community and so on at deploybook.com. So thank you very much. I think we actually have time for a few questions.
You didn't mention configurations, because I also have a lot of Debian servers and a lot of sites hosted, hundreds. And I want to have configurations the Debian way, and most tools are actually not very well handling the Debian way.
Well, my experience with combining Ansible and Debian are very good. So you can use Ansible not only for installation, but also for configuration management. And we've done that. So we started with only controlling the installation and later added the configuration management aspect of that. So in my experience, that works fine. I don't know what exactly for you is the Debian way, but I don't see a big conflict there between. Yes, yes, that works. That works.
PHP and so on. Yeah.
Yes, that works. Nick, you have to unmute the microphone before you hand it.
Yeah. Okay, thanks for the nice talk. I've missed some important thing from me, which is security. You just said it's easier to roll out security fixes, but I think it's easier to put in security bugs. Because for most companies, features are features and security is not a feature. And so they just do a security audit from time to time. And if you do a continuous deployment, then it's, yeah, it's a moving target for a security audit.
Well, you can automate that. So you can use penetration testing tools. That it's not the same as an audit, but you will get some amount of testing. And as I said, you can also do the continuous delivery just to a staging environment, which is not reachable from the outside, wait for the security audit, and only after the audit do the deployment to production.
It's true. Maybe one point, there was a guy a few days ago which found a bug in Facebook, and actually not in the real Facebook site, but in the better Facebook site, which was public, and which made it possible to brute force security tokens used for password resets. So don't deploy to some public beta site.
Yes, so it's actually something you have to clear with management. And I think the time's up. Sorry, you can ask me in private afterwards. Thank you.